Hello, good morning, students. In the last lecture, we had studied about this electronic effects in organic compounds. We know this electronic effects are of different types like inductive effect, resonance effect, electromeric effect, and hyperconjugation. We will study all these effects in detail. So the first type of effect that we will study today is inductive effect. So before explanation of this effect, I will explain this example. Consider this CH3 single bond CH2 Cl. This is ethyl chloride or chloroethane. So in this molecule, the numbering, that is a carbon bonded to functional group chlorine, it is numbered as a carbon number 1, and the next is carbon number 2. Here the carbon 1 and chlorine bond, it is a covalent bond. So we know how covalent bond is formed. This covalent bond is formed by mutual sharing of electrons. So during formation of this carbon chlorine bond, here it is a carbon and there are two electrons present between this carbon and chlorine. So next item is the chlorine, so which consists of this two electrons. These are formed by mutual sharing of electrons. Originally it is a covalent bond. So if a covalent bond is formed between the similar atoms having the same values of electronegativity. What is electronegativity here? Electronegativity means a power of atom to attract an shared electron pair towards itself. That is called as electronegativity. If we consider the electronegativity between carbon and chlorine, here the chlorine is more electronegative than carbon. Therefore, these electron pairs present between carbon and chlorine, these are attracted towards chlorine more and carbon less, because chlorine is more electronegative than carbon, and therefore the formation of delta positive and delta negative charge, that is small positive and small negative charge, it is shown in this molecule. Here the chlorine possesses delta negative charge and adjacent carbon, that is carbon number 1, possess delta positive charge. So this type of formation of charge, that is delta positive and delta negative, or small positive and small negative charge, that develops the polarity in this covalent bond, and therefore this bond is called as a polar covalent bond. So in this polar covalent bond, these electrons present between carbon and chlorine, they are attracted towards chlorine, and this movement of electron towards more electronegative atom, that is called as a inductive effect. Or the definition of inductive effect can be given as the permanent polarization in a single covalent bond due to electronegativity difference, that is called as a inductive effect. Now we will study about the definition of inductive effect in detail. Here the definition of covalent bond is given. We know covalent bond between the two atoms differing in their electronegativity is a polar covalent bond. We had already studied what is covalent bond, then why bond is called as a polar covalent bond. So that is given here. For example, the covalent bond between carbon and more electronegative chlorine is a polar covalent bond. When an organic molecule has a polar covalent bond in its structure, then the polarity is induced, polarity is developed in adjacent carbon single bonds too, and this is called as a inductive effect. In simple words, the definition of inductive effect can be given as it is a permanent polarization of single covalent bond due to electronegativity difference, that is called as an inductive effect. Now, consider this example of chloroethane. In this molecule, a positive polarity is developed on carbon number 2 due to the inductive effect of Cl minus atom bonded to carbon number 1. Normally, carbon 1 and carbon 2 bond would not be expected to be polar because this bond is formed between the two similar atoms and they have same electronegativity values. So originally carbon 1 and carbon 2 bond is not polar bond, but due to polarity between carbon 1 and chlorine bond, the adjacent carbon-carbon bond develops polarity, and that is the inductive effect. So it is a covalent bond between two atoms of the same element of carbon. This bond acquires the some polarity because of the presence of chlorine atom in the molecule. We know chlorine is electronegative than carbon. Therefore, carbon 1 chlorine bond, here there is a printing mistake. Here the carbon 1 and chlorine bond, it is a polar covalent bond with partial negative charge on chlorine. Again here carbon is given, but here must be a chlorine equal to amount of partial positive charge on carbon number 1, as the carbon number 1 is further bonded to carbon number 2. Therefore, the positive polarity of carbon 1 pulls the shared pair of electron of carbon 2 carbon 1 bond, that is between second carbon and first carbon. These electrons are slightly pulled towards carbon number 1 and develops still smaller positive charge on carbon number 2. So in this way, the intensity of positive charge that decreases in the length of carbon as we go away from carbon chlorine bond. The electron density get displaced towards the chlorine atom, not only along the carbon 1 chlorine bond, but it is transmitted along the carbon carbon bond due to the inductive effect of chlorine. So this can be represented as, this is CH3 single bond, CH2 single bond, Cl. Here the due to electronegativity difference of chlorine and carbon 1, electron pairs present between carbon 1 and chlorine they are slightly pulled towards chlorine, and therefore it develops a polarity, that is delta negative charge on chlorine and delta positive charge on carbon number 1. Due to this positive charge on carbon number 1, the electron pair present between carbon 1 and carbon 2, that is also slightly attracted towards the carbon 1, and again here the polarity is developed, but here the difference is that this carbon 1 have delta positive charge having more intensity than the carbon 2 positive charge, and in this way, as the distance between polar bond increases, the intensity of this inductive effect decreases. The arrowhead put in the center of the bond, it is used to represent inductive effect. So how inductive effect is represented? Just put arrowhead on a bond. So in the direction of arrowhead, the electron density is pulled. So the direction of arrowhead indicates the direction of the permanent electron displacement take place along sigma bond in the ground state. Inductive effect of an influencing group is transferred to subsequent carbon atoms along the carbon-carbon bond, and it decreases rapidly as the number of intervening carbon-carbon bond increases, and it becomes negligibly small beyond third carbon atom. And this can be represented with this example. Consider this CH3 single bond CH2 single bond CH2 single bond CH2 and single bond Cl. Here there are 4 carbon atoms, that is carbon 1 is bonded to chlorine, then carbon 1, carbon 2, carbon 3 and carbon 4. So we had already studied that the bond present between chlorine and carbon is a polar due to electronegativity difference, and therefore this chlorine possesses delta negative charge and carbon 1 possesses delta positive charge. Due to this delta positive charge on carbon number 1, the electrons present between carbon 1 and carbon 2 are slightly pulled towards carbon number 1, and that effect extends up to carbon number 3. Therefore here the carbon 1 possesses delta 1 positive charge, carbon 2 possesses delta 2 positive charge, and carbon 3 possesses delta 3 positive charge. Here the intensity of positive charge decreases, meaning is delta 1 positive is greater than, delta 2 positive is greater than delta 3 positive. The direction of inductive effect of bonded group depends upon whether the electron density of bond is withdrawn from the bonded carbon or donated by bonded carbon. According to this ability, the groups of substituent are classified as either electron withdrawing, that is accepting, or electron donating, that is electron releasing groups with respect to hydrogen. In the above example, electron displacement take place towards chlorine. This means that the chlorine withdraws electron density from carbon chain, and the electron, it is a chlorine is electron withdrawing, and therefore electron withdrawing inductive effect is observed due to the chlorine atom, that is called as a minus negative inductive effect or minus I effect. There are some groups which shows the negative inductive effect. These groups are NO2 group, that is called as a nitro group, or CN group called as a cyno group, or COOH, that is called as a carboxy group. Then COOR, this is ester group, and OAR group, that is aryloxy group. So all these groups, if they are present at the position of chlorine in above example, then these groups are electron withdrawing, or it may be present other than the position of chlorine. Where they are present, they show minus I effect, that is called as a negative inductive effect. This is one type of inductive effect. The second type of inductive effect is positive inductive effect, that is also called as a plus I effect. And the groups which show this positive inductive effect are, these are alkyl groups. We know very well the alkyl group examples are, it is a CH3 called as a methyl, or C2H5 can be written as a CH2CH3, this is ethyl. So all these alkyl groups are groups, they show positive inductive effect. So here in this example, if we consider here as a CH3, CH2, CH2, Cl, here the chlorine shows minus I effect. Instead of chlorine, if there is a chlorine, bromine or iodine is present, they also show minus I effect. But the intensity of this inductive effect, that is more in case of chlorine than bromine than iodine. Therefore, chloride compounds are show more inductive effect than bromide than iodide, and the type of inductive effect observed due to this halogens, it is a negative inductive effect. So today we had studied about inductive effect. The definition of inductive effect is, it is a permanent polarization of single covalent bond due to electronegativity difference, or the polarity in the adjacent carbon-carbon bond is observed due to the polarity present between the carbon and the electronegative atom like chlorine, bromine, iodine, or the groups that we had studied in the negative inductive effect showing groups. So inductive effects are two types, that is minus I effect and plus I effect. Remember these examples of the groups which show minus I effect and the plus I effect. And that is about the first type of effect, that is called as a inductive effect. Thank you.